Hi, I am Mohammed, and in today's lesson, we are going to take linear equations to the next step by solving real life word problems. Many students can solve equations when they are written out, but word problems often feel tricky. So, by the end of this video, you'll see that they are actually just stories written in maths, and by that, let's get started. So, I have a question that states the sum of two numbers is 20 and their difference is 6. So, the sum of two unknown numbers, you can take those numbers as x plus y, and it is 20. So x plus y is equals to 20 becomes my first equation. It further goes on to say that their difference is 6. So the difference between these two numbers is 6. Difference is subtraction, so I wrote it as x minus y is equals to 6 over here, and it became my second equation. Now this is simultaneous linear equation, and we have two ways of solving simultaneous linear equation: by elimination method or by substitution method. I use elimination method, so let's look at it. In elimination method, we add or subtract both equations to get rid of one variable. So you can see that if we add both of these equations, we would get rid of y. I did just that. Add both equations. X plus x is 2x, and plus y minus y becomes 0. 20 plus 6 is 26. And then just divide it by 2 to get rid of this 2 over here. So divide by 2, 2 get cancelled, and 2 13s are 26. So x becomes 13. Now in elimination method, when we get our first variable, we substitute that variable into any of the equations. So I substituted x into equation 1, and equation 1 was x plus y is equals to 20. Upon substitution, 13 plus y is equals to 20, and 13 plus y is 20. So we subtracted 13 from both sides to get rid of the 13 over here. So 13 minus 13 plus y is equals to 20 minus 13. 13 minus 13 becomes 0. Y. 20 minus 13 is 7. So we have got both variables x and y. So our two numbers were 13 and 7. My next question says that a father is 3 times as old as his son. In 10 years, the father will be twice as old as his son. Find their present ages. So a father is 3 times as old as his son. Let's take son's age as x. Son's age is equals to x, and father's age is 3 times of that, so 3x. And in 10 years, son age will be x plus 10, and father age will be 3x plus 10, right? Because in 10 years they'll both be 10 years. Their age will be added by 10, right? So it was given that in 10 years father will be twice as old as his son. So we take our current equations. That was father age is 3x plus 10, and it will be 2 times of son age, right? So son age is x plus 10, right? In 10 years it becomes 2x plus 10. So 3x plus 10 is equals to 2x plus 20. To get rid of 2x from over here, because we need only variable on only one side of the equation, to get rid of 2x from here, we subtract 2x from both sides, right? So 3x minus 2x becomes 3x minus 2x plus 10 is equals to 2x minus 2x plus 20. 3x minus 2x is x, and plus 10. 2x minus 2x is 0, and we write 20. Now we get rid of 10 over here, so we subtract 10 from both sides. X plus 10 minus 10 is equals to 20 minus 10. So x is equals to 10. We got our first variable, that is x. I mean, we need only one variable over here. So son is 10 years old and father is 30 years old, because father was thrice of age of his son, right? As of right now. My next question is that one pen and two pencils cost $12, while two pens and three pencils cost $19. Find the cost of each pen and pencil, right? So we take cost of pen as X and cost of pencil is equals to Y. It said one pen and two pencils, meaning X plus 2Y is equals to 12, because Y is 2 and we had two pencils, right? So multiply by 2. And while two pens and three pencil cost $19, pens is X, so 2X plus 3Y is equals to 19. We got ourselves a simultaneous equation, and we can solve it by either elimination method or substitution method. I solved this question by substitution method, so let's look at it. In substitution method, we used to uh, isolate one variable from one equation and put the value of that variable into the other equation. So I took equation 1 and started isolating x. So equation 1 was x plus 2y is equals to 12. To isolate x, we have to get rid of 2y from over here, right? So subtract 2y from both sides. X plus 2y minus 2y is equals to 12 minus 2y. This 2y minus 2y becomes 0, and we've got ourselves equation of x, that is x is equals to 12 minus 2y. Now we substitute this value into the other equation, that was equation 2. Equation 2 was 2x plus 3y is equals to 19. So by putting the value of x, 2 multiplied by 12 minus 2y plus 3y is equals to 19. I just put this value into x over here, right? So 12 2s are 24, and 2 multiplied by 2y is 4y. So 24 minus 4y plus 3y is equals to 19. Minus 4y plus 3y becomes minus 5, and we have got 24 minus y is equals to 19. By subtracting 24 from both sides, we get 24 minus 24 minus 5 is equals to 19 minus 24. 24 minus 24 becomes 0. We've got minus 5. 19 minus 24 becomes minus 5. So now the both subtraction side will get cancelled, and we have got ourselves y is equals to 5. Now we put this value of y into our equation of x, because it was 12 minus 2y. We have to get rid of the variables. So my equation of x was x is equals to 12 minus 2y, and my value of y is 5. So I put it in y. 12 minus 2 multiplied by 5 is 12 minus 10, and 12 minus 10 is 2. So we've got our both variables, x is equals to 2 and y is equals to 5. X was the cost of pen, so pen is of $2 and pencil is of $5. In these type of word problems, you have to write our answer in form of wording too, because in maths the nature of question we get it, we have to reply in that nature, right? This is my next question, and I want you to solve it on your own and comment the answer below. My question said that Albert bought 2 pens and 3 pencils for a total of $24. His friend Sarah bought 3 pens and 2 pencils for a total of $28. So we are going to do the same thing. We make one equation of the first line and the other equation of the second. We got ourselves a simultaneous equation, and we solve it by either by substitution or elimination method. whichever you like. So I want you to solve this equation and comment the answer below. I'll tell you if you have done it right or wrong, right? So that's it for today's lesson on word problems in linear equations. Remember, the key is to carefully translate the English into equations. You already know how to solve the linear equation. So just you have to just solve the equations. And if you want more step by step help in math, you can book a trial lesson with me. Link is in bio. See you in my next video. Thanks for watching.